So today we are working with polynomials and rationals. So polynomials technically was last chapter, but they all kind of go together. And we're going to do something. There's a couple things that we do all the time. Like we've done a lot of different scatter plots. We did linear, we did quadratic, we did cubic, we did quartic. Okay. We've done inequalities now. We did inequalities with parabolas, we did inequalities with polynomials, and now with rationals as well. Okay. So this right here, pretty easy, at least in bell work here. Use the graph of f of x of this thing, this thing, this thing. What does that tell me? Well, that's my zeros. My zeros at -3, my zeros at 1, and my zeros at 4. So based off of those three things, we're trying to answer these questions. When is f of x equal to 0? Well, that's what we just did. F of x is equal to 0 at x is equal to -3, 1, and 4. Make sense? Where it's equal to 0. Next thing we're doing is when f of x is greater than 0. When do you think f of x is greater than 0 here? Sai, what do you think on that one? When am I greater than 0? Yep. Yep. 4 to infinity. And -3 and 1 are using brackets or parentheses there. Parentheses, good, because it's just greater than, not greater than or equal to. Same thing here at 4 and at infinity. So what he's answering there is when is my function greater than 0? When are my y values greater than 0? Well, when it's above 0, when it's positive. So that area right there and that area right there, and this is a polynomial, so we know that this line is going to continue upward forever and ever and ever. It's not coming back to 0, okay, because it's a cubic polynomial. I've already got my 3 zeros. That's easy enough. And then we're going to find when f of x is less than or equal to 0. When do you think f of x is less than or equal to 0 here, Caroline Cook? And 1 to 4. Brackets, obviously a parenthesis there. Bracket or parenthesis at -3. Bracket there and here to here. That's it. Don't make it harder than that. It's just looking at the graph and understanding it. This concept itself is something we're going to use a ton in calculus later on. You're going to use it in Calc BC in the very first thing you learn next year in August. So this is something we're going to understand. It's really easy today, but it does apply later on. This is the last thing that we're learning in this chapter. You can kind of see where it fits in a little bit, but it is kind of strange too. It is different, okay? But it's the same idea that we've been dealing with. What we're going to do here is it's going to take a two-dimensional picture and make it even more simple. We're going to make it into just like a one-dimensional picture. So x and a y-axis, we're going to take that information and put it just into a number line. Okay, so here's what that means. We are trying to decide when is this graph positive or negative. That's basically what we're trying to decide. When is this graph positive and negative? That's the main idea. And so we made a number line down here, and we marked certain spots. So you can see here we marked 3, we marked 0, we marked 4. What were those three things on the graph? Those are x-intercepts. -3, 0, and 4. And then once we've marked those zeros, it's just a matter of marking. Am I positive or negative before that? So everywhere before -3, my graph is above the x-axis. So these are all positive. And then from -3 to 0, oh yeah, everything, it's above the x-axis. So that's all positive. From 0 until 4, I'm below the x-axis. So we marked it negative. And from 4 on, we were positive again. It's just taking that information and breaking it down into an even simpler concept. See visually what's happening there. Let's do it again. So that's with a polynomial. Polynomials are pretty easy. This is a rational. Same idea, though. It's a rational. Notice the spots that we marked. We marked -2, 1, and 4. So -2 and 4, those are obvious. Those are x-intercepts. Where is the other place that we can change from being positive to negative? What is that 1 right there? What is that a mark for? Vertical asymptotes. That's what we're looking for today. We're looking for x-intercepts and vertical asymptotes because those are the two times where my function could change signs. The only place that I can change from being positive to negative or negative to positive is at vertical asymptotes and x-intercepts. There's no other time that your graph changes from positive to negative. Okay? So keep that in mind as we work through this. Let's do number 1. So it says solve the inequality. X cubed plus 16x is less than 8x squared. So the first thing we're going to do is solve that thing. Like any polynomial, in order to solve it, we're going to make it equal to 0. All right, so we get x cubed plus minus 8x squared plus 16x. That needs to be less than 0. And although that looks weird, you can totally do it. Go ahead and factor and solve. Find your answers. Go. All right, here we go. So we are trying to solve this thing. Sam, what'd you do here to solve? Took out an x because everything's got an x in it. So we factor out an x. We get x squared minus 8x. I forgot my x up there. Plus 16. Cool. Then we got to keep factoring. What'd you factor that into?
X minus 4 squared.
Yeah, x minus 4 squared. I'm going to write it out the long way, but x minus 4 squared is a great way of writing that. Okay, and that thing right there needs to be less than 0. Once we factored it, we could solve it pretty quickly. Obviously, we know that the answers, my x-intercepts here, are going to be at 0 and 4. All right, but our goal here is to understand when am I less than 0. So the best way to do that is to make a sign chart. Okay, just a number line. And it's going to be the most basic number line of all time. All we're putting on that sign chart, on that number line, is our places where we could change signs. And that's at x-intercepts and vertical asymptotes. So for us, I'm going to mark 0 and 4. So I just throw those numbers on there. And then all I need to do from there is decide what's happening in the other places. Okay, these are the only places it could change signs. And so what I want to do now is decide I need to pick a number that's less than 0. Pick a number that is less than 0. -1. Great. It doesn't matter what number you pick. Any number less than 0 is going to give you the same result. We're plugging -1 into our factored down form right here. You could really plug it in anywhere, but it's easier to plug it into this factored down form. But I'm taking it right here. I'm going to plug it into this thing. If I plugged in a -1, this would be negative. I don't really care that it's -1. I just care that it's negative. That would be negative. What happens if I plug a -1 in here? Would it be positive or negative? Negative. If I plugged a -1 in here, it would also be negative. What's going to happen if I take 3 negatives and I multiply them together? It's negative. No matter what negative number you picked, if I were to plug in a number less than 0, I would get a negative answer. And so that means every number less than 0 is going to be negative. That's what we figured out. Next thing we're going to do is pick a number between 0 and 4. So if I'm picking a number, what number can I pick between 0 and 4? 2. Great. Doesn't matter. If I plugged in 2 for x, that would be positive. If I plugged in 2 here, 2 minus 4, is that going to be positive or negative? That's negative. That's also going to be negative. I have a positive times a negative times a negative. What's it going to get me? Positive. So any number between 0 and 4 is going to be positive. No matter what number we picked. If you picked 1, if you picked 3, you picked 2.5, it was going to be positive. And then I want to pick one more. I want a number bigger than 4. So 5. Great. If I plugged in 5, this would be positive. This would be positive. This would be positive. So every number bigger than 4 is going to be positive. That's my sign chart. That's an important concept. Talk with your neighbor for a second. Why did I not change signs at 4? Talk with your neighbor. 4 is an x-intercept. Why did I not change signs at 4? So we made this sign chart. We picked these spots in particular because we thought that's where it was going to change signs. Evelyn, why did it not change signs at 4? It just touches. What this means, this x minus 4 is happening twice. The multiplicity is 2. So I'm not graphing it, but I know what it looks like. Okay, I know that I'm crossing at 0. And I'm going to 4, and then I'm going to touch at 4. So I went negative, positive, and then I was positive some more. Okay, that's visually what's happening with that graph. But we were able to put that into a number line and understand the same concept. Sorry, I don't like the highlights there. It throws me off. Okay, so last thing we're going to do is just answer the question. The question is, when is this thing less than 0? And so my answer to that question is simply negative infinity to 0. This section right here. That's when I'm less than 0. Any number less than 0 got me a negative number. A number less than 0 So that is my answer, negative infinity to 0, parentheses on 0 because it's just a less than sign. Questions on number 1? Let's do number 2. Number 2 says, solve this rational for when it's greater than or equal to 0 by graphing it. Okay, sometimes Microsoft Word deletes letters, but that just said f of x. Cool, we're going to solve it by graphing, so break out your calculator. So in my calculator, I'm typing that thing in. So it is this x minus 1, x squared minus 4. So get my fraction button, x minus 1 over x squared minus 4. If you haven't messed with your calculator in a while, you might want to go zoom 6 so you can see the basic picture. I think mine's zoomed in a little bit. I don't know. Let's just go zoom 6 just so we can all see the same. Cool. There's my picture. So this one's really easy. This is just like bell work in terms of I don't have to do a ton of work. It's just understanding how can I interpret this picture? Okay, so once we've got this picture, once we've got it graphed, we're still going to make a sign chart just like we did before. Okay, so make a quick sign chart. A sign chart is just a fancy name for this number line where I put signs on it. I have one x-intercept. It's right there at negative 1. Yes, ma'am.
Do we have to make that sign chart?
Yes,
Okay.
I want you to.
Test, it'll be like the quiz.
Sure. Yep, it's definitely something we're going to do in calculus, and when we do it algebraically, sign charts are very important. So that's why I want you to get practice with them.
Just out of curiosity, is it like sign as in like the trigonometry thing?
No, sign as in like I'm putting plus and minus signs on it.
Okay.
Good question. Okay, so I marked my x-intercept. Just like before, we want to mark x-intercepts. What other places on this graph do I change signs? At vertical asymptotes. So not only am I marking my x-intercepts, but I'm also going to mark my vertical asymptotes. So where did my vertical asymptotes happen? Well, on bottom I got x squared minus 4. So I'm guessing that I'm getting them, and you can see it from the picture, at negative 2 and positive 2. Okay, that's the other places on my graph where I could change signs. Once I've done this, then I'm just going to fill it in. And this is really easy with a picture. But less than negative 2. Everywhere to the left of this line right here, am I positive or am I negative? I'm negative for sure. I'm below the x-axis, so that's negative. Then from negative 2 to 1. So from that line right there to right here, I'm definitely positive. I'm above the x-axis. From here until here, I'm positive. I'm above the x-axis. And then from 1 until 2, oh yeah, I'm negative again because I'm below the x-axis. And then from 2 on, I'm above the x-axis again, so it's a positive sign. There's my setup. It's just, again, taking this picture and putting it into a sign chart, into a number line. Cool. Now we're just going to answer the question. The whole question was, when am I greater than or equal to 0? Talk with your neighbor for a second, and be careful with your grouping symbols, your parentheses and brackets. Think about it. All right, here we go. We are writing when I am greater than 0, greater than or equal to 0. So I'm going negative 2 to 1. Okay, obviously from negative 2 to 1, I'm above the x-axis. A bracket or parenthesis on the negative 2. Bracket or parenthesis here. Oh, we said both. Tell your neighbor, why is it a parenthesis and not a bracket? So at negative 2, we're going to put a parenthesis instead of a bracket. Anybody want to explain why we're putting a parenthesis? Kendall, what do you think? We're not touching it. At negative 2, there's nothing graphed. There's a vertical asymptote. So I'm not equal to 0 at negative 2. I'm not anything. It's undefined. Okay, so at negative 2, I used a parenthesis. What about at 1? Bracket or parenthesis at 1? Bracket, because at 1, I'm right there. I'm on the line. I'm 0. I'm equal to 0. That's what I'm trying to be. Am I greater than or equal to 0? Yeah, I'm equal to 0. So I bracket that. Okay, that thing, and from 2 to infinity, obviously a parenthesis on infinity because it's always parentheses with infinity. What about at 2? Parenthesis as well, because again, it's a vertical asymptote. And so it might help you when you make your number line, label those things as vertical asymptotes so you don't forget that, because it is different than a x-intercept. So just having a vertical asymptote label of some sort by it, it's helpful. Everybody go with 2? All right, one more. This is less helpful, I would say. Same concept. The concept doesn't change at all. But every time we do this in calculus, we're always doing greater than or equal to 0. Here we decide to do greater than or equal to 3. That's fine. Okay. The same rules apply. The only time that I'm going to change signs is when I have a vertical asymptote, or in this case, when I'm equal to 3 instead of equal to 0. But everything else is the same. All right, so let's make a sign chart. What number do I know is going to go on that sign chart? -2. I've got a vertical asymptote right here at -2 because it's x plus 2 in the denominator. It's not a whole. It's a vertical asymptote. Okay, so I can go ahead and throw -2 on this sign chart. And then I got to find where I'm equal to 3. Now, I don't really got to find my zeros or my x-intercepts, but in this case, I got to find my 3's. When am I equal to 3? And so just like we did the last couple days, 4x plus 5 and x plus 2, I want to know when it's greater than or equal to 3. I really just care when it's equal to 3. But I need to solve that. Okay, go ahead and solve that real quick. Should get positive 1 here. We are subtracting 3x. I get x. I'm going to subtract 5. I get 1. So on my sign chart, not only am I going to put this -2, which is a vertical asymptote, I'm also going to mark 1. Okay, that's an intercept. An intercept of 3 here, but we're good. Great. Then all I have left to do is plug in. And so in this case, I got to plug in numbers less than -2, between -2 and 1, and greater than 1. And I'm trying to answer the fact, am I greater than or equal to 3 or not when I plug in those numbers? Okay, so for example, what's a number less than -2? Plug in -3 and decide, is that number that you get greater than or less than -3? Take a second and do that. You don't need a calculator for this. Use your brain. Thumbs up if the number I get is greater than 3. Thumbs down if a number is less than 3. Should be greater than 3. I'm going to put a check mark because it's not really plus and minus. It's really yes or no. Okay? If I plugged in 3, it'd be 4 times -3 plus 5. That gets you -7. And on bottom, I'd go -3 plus 2. That would get me -1. Oh, yes, 7 is greater than 3. I'm good. Okay? Then I got to pick a number between -2 and 1. What number should I plug in between -2 and 1? Plug in 0 because 0 is the easiest. If I plugged in 0, that would go away. I plugged in 0, that would go away. It's 5 halves. Is 5 halves greater than 3? No, so that's a no. The last one, a number bigger than 1. So pick a number bigger than 1. 2. Plug in 2. If I plugged in 2, I would get 8 plus 5. I'd get 13 over 4. Is 13 over 4 greater than or equal to 3? Yeah, it is. Write your answer now. Okay, so now that we've done that, write your answer in interval notation. See what you get. We're writing this thing in interval notation. What'd you say for this one, Alex? -infinity, -2, both parentheses. Why are you putting a parenthesis at -2? It's a vertical asymptote. So again, if it's a vertical asymptote, I'm not going to actually cross it. And where else? Good. This is his answer right here. You do have a graphing calculator, so you can check this. Okay, let's type it into our calculator real quick just to see it. Okay, so it's 4x plus 5 over x minus 2. Is it x minus 2 or plus 2? My fault. X plus 2. Okay? And I'm graphing the number 3 because I want to know when am I greater than 3. So I type that in. I'm going to hit graph. When am I greater than 3? Well, I said I was greater than 3. Alex said from there all the way up here until 2. And at 2, I'm not actually greater than 3 or negative 2 because at negative 2, there's a vertical asymptote. So from negative infinity to negative 2, parentheses around both. And then the other time we did it was from 1 on. And at 1, I want to include it because I'm equal to 3. From 1 on, I'm greater than or equal to 3. That's what I was looking for. Questions on something we did today? Backside.